Hi guys. So Mrs. Reynoso tells me that we are going to have a test on Friday. So I am going to go over the review for chapter 16 with you. So starting on page number 485, we have from 16.1, the measures of center. Number 1, find the mean and median of this data. So it's giving me 2, 5, 9, 11, 17, 19. The way that we find the mean is by adding all of those numbers together. So 2 plus 5 plus 9 plus 17 plus 19, oops, I missed the 11, plus 11 equals, and we take our calculator. Just a second, I seem to be missing. Okay, so I have my calculator now. Adding all those together, I end up with 63. Then I divide it by how many I have. So I have 1, 2, 3, 4, 5, 6. So I do 63 divided by 6, which equals 10.5. So my mean is 10.5. My median is literally the number that is in the middle. So I go in 1, 2, 3. So the number between the 9 and the 11 is 10. So my median is 10. Number 2, the mean absolute deviation. Find the mean absolute deviation for these same numbers that we have up here. Round to the nearest hundredth. All right, just a sec. Okay, so the way that we do the mean of absolute deviation is we already figured out that our mean is 10.5 for this one. So we have to see how different each of these are from 10.5. So I do 10.5 minus 2, which is 8.5. 10.5 minus 5, which is 5.5. 10.5 minus 9, which is 1.5. Then I'm going to switch it around and I'm going to do, because these numbers are larger, and remember the differences always have to be positives. We are never going to have negatives here. So my 11 minus 10.5 is 0.5. My 17 minus 10.5 is going to be 6.5. And 19 minus 10.5 is going to be 8.5. You can use your calculator for that one. It's perfectly fine. Then I take these numbers right here, the differences. I take all of those and I add them together. So I add all of those numbers together. Let me do that with my calculator. 8.5 plus 5.5 plus 1.5 plus 0.5 plus 6.5 plus 8.5 gives us 31 as a total. And then I divide that. All right, give me a second. My hookup apparently turned off first. Okay, so I added all of these together. I got 31. I have 6 numbers I'm dealing with, so I am going to divide by 6. 31 divided by 6 equals 5.16 repeating. That's what that line over the top of it means. So our mean of absolute deviation for it is 5.16 repeating. Okay. Number 3, the box plot. Okay, so let's make a box plot with this information. I have a 36, 42, 44, 52, 61, 70, 78. Okay, so I have to figure several things out. I need to figure out where the absolute middle is. So going in, 1, 2, 3, 4. So that's our absolute middle number. Now I need to find the middle of the lower side, which is right there. And now I need to find the middle of the higher side, which is right there. So those are the 3 numbers which are going to go onto my number line as the lines that our box is going to go across. So I'm going to pause while I make up the number line, and then we'll place it. Okay, so this is a number line that looks similar to the number line that they gave you. The first line is going to be at 42, which is going to be around here-ish. Second line is going to be at 52, which is going to be around here-ish. The third line is going to be at 70, which is going to be exactly there. And then I'm going to connect those 3 to make my box. So there's my box. My lowest number is a 36, which is going to be around here. My highest number is 78, which is going to be around here. Then I'm going to connect those dots in with lines. And now I have my box and whisker plot for that. Number 4. I need to get another sheet of paper. So pause it if you need to. I am moving on. Number 4 says, we have a baseball team which scored runs 6, 6, 8, 5, 4, 6, 4, 3, 8, 4. And then we need to make a dot plot for this one. It looks like it wants you to put in both the numbers as well as the X's for it. So you have the line, then you want numbers 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. And then you can put in your X's above it. So I have 2 6s, I have an 8, I have a 5, I have a 4, I have another 6, I have another 4, I have a 3, I have another 8, and I have another 4. I'm putting in X's instead of dots. You can put in dots if you want to. It really doesn't matter. We end up with exactly the same thing either way. For number 5, we need to find the mean, median, and range of this information. Okay, so once again, mean is literally adding all of these numbers together. 5 plus 4 plus 6 plus 4 plus 3 plus 8 plus 4. Okay, so I am going to do 6 plus 6 plus 8 plus 5 plus 4 plus 6 plus 4 plus 3 plus 8 plus 4 gives us 54. Divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 54 divided by 10 is 5.4. Because the 0 says move it over 1 time. So that is our mean. our median. For our median, I'm going to use this one, not this one, because this one's in order. So 1, 2, 3, 4, 5. So it's halfway between the 5 and the 6, which is 5.5. That is halfway between 5 and 6. Then we have range, which is the largest number of 8 minus the smallest number, which is 3. 8 minus 3 is 5. So that is our range. Our range is 5. Now we can go on to number 6, where we are going to make a histograph. All right. So I am going to make it on my graph paper. You already have graph paper inside your book. Let me see. Okay. So we have going up, we have 0, 1, 2, 3, 4, 5. First is 1 to 10. Then we have 11 to 20, 21 to 30, 31 to 40. Oh my goodness. Okay, you know what? I'm going to just put it on the side and do it this way. 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50. How high up does this go? 70. 51 to 60, 61 to 70. Okay? So then I'm going to flip it this way so it looks the way that your guys' does. Now let's look at the information that they gave us to put on this graph. First number is 23. Second number is 45. Third number is 62. Fourth number is 19. Fifth number is 48. Sixth number is 10. Seventh number is 39. Eighth number is 54. Ninth number is 39. 10th number is 16. 11th number is 48. 12th number is 12. 13th number is 25. 14th number is 32. 15th number is 18. And 16th number is 4. So simply by putting it in exactly where it should be, one square at a time, I made the entire histograph that it wants me to make. Okay, it's not all that difficult. Then number 7, how can you represent and summarize data in a dot plot? Okay, so I guess you can make marks above a number line to show how many of each number you have. And then that's also how you know what to summarize, because when you look at the dots, you know what the summary is for that. Any event, page 486, the other half of it, the assessment readiness. Number 1, it says, sorry, I'm moving the paper all over the place. Consider the box plot. Select yes or no to indicate whether the statement is correct. So the interquartile range, that is the top and the bottom. So when we have our box that looks like this, from here to here, that's what we're talking about for the interquartile range. So it looks to be, well, it can't possibly be 20. I don't know what the top number is, but in order for the top number, in order for the interquartile range to be 20, the top number would have to be 40, because the bottom number is obviously 20. And it's not 40, so there's no way that it is 20. The median of the data is 30. So when we're talking about the median, we are talking about that line that is directly in the middle. And that line is in fact at the 30. So yes, the median is 30. The least data value is 10. When we're talking about the least data value, we're talking about that one, the end of the whisker on the left side. And the end of that whisker is in fact the 10. So yes, that is the least data value. Number 2, Hal asked some quiz show contestants their ages. This dot plot shows his data. Most of the data values are clustered at or below the median. While looking at it, it looks like the median is either 21 or 22. I mean, I can figure it out exactly. I can go in. And almost everything is 22 or lower. So yes, I would definitely say that it's clustered at or below the median. Letter B, Hal collected data from 13 contestants. You literally count how many dots there are. Are there 13? There you go. C, if a new data value 30 is included into this data plot, the median would increase. So if I added one more value, would it increase? That really depends. 2, 3, 4, 5, 6, 7. No, because the median was 22 to begin with. And then if I added one more value, the median would go down one number, but still be in 22. It would just go down one dot. Number 3, Andrea recorded the points that she scored in her last 8 basketball games. 28, 32, 47, 16, 40, 35, 38, 54. Give an example of a statistical question you could answer using the mean or median. Explain your reasoning. So remember, the mean is your average. So we could ask, just for example, we could ask, how much does Andrea score on average? And we could answer that with the mean. Number 4, This frequency table shows data about the number of tickets sold by students. So you are once again simply going over and plugging in each of the values and shading up the correct number. So for 0 to 9, you're shading up 2 of the blocks. For 10 to 19, you're shading up 4 of the blocks. For 20 to 29, you're shading up 3 of the blocks. And for 30 to 39, you're shading up 1 block. That's all that you're doing. It's not super complicated. How many students sold tickets? So then all you need to do is add together all the numbers in your frequency table so you can find out how many sold tickets all together. So 2 plus 4 plus 3 plus 1. And then what percent of the students sold 20 or more tickets? Okay. So let's look at this for just a second. If I know from letter B that 10 students sold tickets, for letter C, I need to know the percent who sold 20 or more. So 4 of them sold 20 or more. So 4 out of the 10 sold 20 or more. So I need to do 4 divided by 10. Which is 0.4. Now, it wants to know the percent, not the decimal, so I need to change this decimal into a percent. I move it over 2 times, always 2 times. I don't care how many numbers you have, it always goes 2 times. So it becomes, and then I put in a 0 there because I don't have enough. 0, and so it becomes 40%. And that is the end of the review for it. Good luck on your test. See you later.